on Prime Media Plus
on DSTV channel 885
and across the city
on 567 AM.
Welcome back, Views and News through till 12. It is 9:36, and that big appointment every Friday, just after news headlines at 9:30. We connect with the Naked Scientist, Dr. Chris Smith, lecturer at the University of Cambridge. He joins us on air once again to answer a variety of science-related questions. Well, it doesn't really matter. Throw it at him, and you can use the WhatsApp line on 072-567-1567. You can send a voice note. We have a couple of those already, or a text note. You can also call and jump the queue on that telephone number 021-446-0567. Welcome, Dr. Chris Smith. Great to have you back.
Hello, Clarence. Good morning.
Right, are we going to jump right into it? Let's go to the voice notes. Plenty that we need to get through today. Joe.
Good morning, Clarence and Dr. Smith. Flores here from Worcester. Clarence, I want to ask Dr. Smith a very important question. I think it's something that's both dear to me and to you. Dogs, why can't they navigate their way back home if they are a certain distance away from home? I just want to find out what the science is behind that dogs cannot find their way back home, most dogs. Yeah, because my neighbor's dog has been running away for some time, but every time he would come back within a day. But this time he's been away now almost for 4 days. His name is Zuma. Please don't ask me about the name. Yeah, and I jokingly said to my neighbor, maybe we'll come back after the elections. You see, everyone is on the campaign trail now. Have a good job. Bye-bye.
I guess the question is, did Zuma push his luck?
The question that's being asked is, dogs and navigation, finding their way home, yes, no, do they get lost? Well, animals are exceptionally good at navigating. They've got really good memories for where they go, where they've been, and how to relate where they are right now with their surroundings. And this is because their life depends on it. And even simple animals like rats and mice know where they are, and even ants know how to navigate. Ants do it by counting their steps. But bigger animals like dogs, cats, mice, rats, they have a structure in the brain that we share with them called the hippocampus. And this hippocampus has particular combinations or clusters of cells which are called place units or place cells, discovered initially by a guy in London called John O'Keefe, who actually taught me when I was an early career scientist. And these fire off and tell animals where they are in relation to certain places in their environment. And as animals explore, they form a very intricate map using these place cells in their brain of where they are in relation to other things, other objects, and where they've travelled. And so as long as an animal has enough cues to go on, it can usually find its way very, very well. And dogs do know their way around exceptionally well. But obviously, if you take them too far away, they will get lost. And the reason is that they are divorced from those cues and connections and those mental maps that they've made. But usually they do have a good sense of direction and they can find their way back home. And then there are some extraordinary stories of animals that have found their way tens to hundreds of kilometres or more under certain circumstances. So I wouldn't say that dogs get lost easily. And despite the fact they don't have anything like the visual prowess we do, they're much better at tuning into their other senses in order to find their way around. So I dispute the notion that dogs get lost easily. I argue that, in fact, they're very good at navigating, as are many other animals.
Maybe your neighbor should just close the gate as well, since there's a pattern that has emerged over time. And the matriarch, Amy says you can't get away with that. You're going to have to explain how ants count their steps.
Well, the evidence for this was published in the journal Science about 10, 15 years ago. And what researchers did was to look at ants coming out of their nests and going for a walk, because ants make forays to go and collect food, for example, and they follow trails laid down by other ants. But they find their way fairly unerringly back to their nest. And it really matters with social animals that they don't get lost, because they can't just camp out anywhere. Their success depends on, and their survival depends on, the fact that they are part of a colony. And the colony suffers if they lose an ant, and the ant suffers if it loses its colony. So they're very good at navigating. And researchers found that if they lengthened the legs of ants, and they did this by gluing hairs clipped off of pig skin onto the ants because pig hairs are about the same gauge as ants' legs. So they effectively put the ants on stilts. And this meant that the ants' strides were made much longer because their legs were on stilts. So every step they took was twice the length it should have been. Now, if the ants were just navigating using other cues to find their nests, then it wouldn't matter the fact their legs were longer and they were taking longer strides. They'd still get home unerringly. What the researchers found when they did that was the ants went twice as far as they should have done to go in the right direction, but they overshot their nest. And this argues that they did it to the proportion of the length of their legs increasing, so that meant they were counting their steps. And then they did the converse experiment and shortened the ants' legs. Pretty evil experiment this, but they chopped a lump off of their legs, so their strides are now much shorter, and the ants undershot the distance to their nest by about the same proportion. So this tells you the ants are counting their steps as well as integrating other cues and smelling signals that the other nestmates have laid down to help lead them to and from food in the nest.
Another interesting little comment in via WhatsApp. Ants count, Zuma can't count. Okay, let's go to another voice note.
Hi, Dr. Smith. This is Logan from Edenville in Joburg. I just wanted to ask, would it be possible for us to do a greenhouse effect on Mars with enough plant life that we can try and grow like a greenhouse and then release that gas into the atmosphere to make the atmosphere actually breathable? Because if it had enough greenhouse gases, wouldn't it be able to retain heat and make it a bit more livable or close to livable for us people, I mean?
Great question, and the answer is we know that this can work because that's exactly what happened here on our planet. Because about 4.5 billion years ago, when the Earth was young, just forming, it didn't have anything like the conditions it has today. And microorganisms, initially cyanobacteria and their relatives, which churned out oxygen, changed the composition of the atmosphere from one which was completely useless to us to what we have today. And this atmosphere is supported now by green plants, algae in the oceans, and there's a balance between various things contributing gases to the atmosphere and various other processes removing those gases, and it keeps an equilibrium. But the wrinkle here is it took billions of years to do that, and billions and billions and billions of these microorganisms and plants and algae and so on to create an atmosphere around a planet. Now, Mars is a bit smaller than the Earth, but on the grand scheme of things, it would be a huge undertaking in order to achieve this in a reasonable timescale, because it took billions of years for it to happen naturally with trillions of helpers here on Earth. So while the concept is a reasonable one, you can terraform a planet in this way, it's really difficult practically and very, very time-consuming. It's not something that a human lifetime, I think, probably we would be able to achieve.
A question in for the Naked Scientist. Why can you sometimes hear aeroplanes flying in the air and on others days not? Keith, with that question.
Keith, hi. The answer to this is, well, if you can hear something, those are sound waves, which are compression waves, which are going from the sound source, which is the aeroplane, and reaching your ear. And therefore, the question becomes, why did the sound waves reach you sometimes and not other times? And there is a range of reasons why this is. One is that the plane's distance will make a difference, and sound attenuates with distance. And this is because the energy, which is compressing the air in a compression wave between the aeroplane and your ear, this is going to dissipate with distance. So the greater the distance, the weaker the sound, and it may be that it eventually is so far away it falls below the threshold of your hearing. The other point is that sound waves are going to be affected by the movement of air, because when you make a sound wave, you are cannoning molecules into the molecules next door, and it propagates like a domino effect through the atmosphere to get to you. So if you blow the air away, you will affect the ability of sound to reach you. And the other consideration is the frequency, because sounds which are lower in frequency will have a better chance of making it across a longer distance than higher frequency sounds. And so different aircraft making different ranges of frequencies in different air conditions, different wind conditions, and at different altitudes are all going to be experiencing these effects to greater or lesser extents. And this will affect your ability to pick up the sound and to discern where this thing is in the air.
Let's go to Ricky's question. Ricky wants to know, if you drill deep enough on the moon, will you find any precious metals like diamonds? Or is the moon hollow?
Hi, Ricky. Well, the moon is made from the crust material of the Earth. And about 4.5 billion years ago, when the Earth was just forming, another planet splatted into the Earth, we think. They were on collision course. And the collision ejected a whole heap of the surface material of the Earth into orbit around the Earth, and over the subsequent millions of years it slowly coalesced into the moon. And this is why when we look at the composition of the moon, we actually have very significant amounts of moon rock because of the Apollo missions and other samples that have been collected since. We know that the moon is largely the same crust material as Earth. And it's largely unchanged because there was some volcanism on the moon when it first formed. We know that there was a hot centre, and there may still be some heat in the centre, and some tectonic activity because there's magnetic evidence for that when the moon was presumably young and still very hot from that collision. But it's cooled down and sort of frozen in time. So the processes that give us many of the minerals that rise to the surface in volcanoes on Earth, the temperatures and pressures that give us things like diamonds on Earth, those are not being experienced on the moon anymore. That's not to say there aren't some things there, and there are going to be some materials there in great abundance, but there are going to be other things which are less abundant on the moon and less easy to get to because we don't have the same processes operating on the moon like volcanoes to bring heavy metals from the centre right up to the top like we do on Earth.
Zuki's on the line. Let's go to Zuki in Big Bay. You've got a question for Dr. Chris Smith. Go ahead.
Hello, Clarence, and hello, Dr. Chris. So I've been thinking a lot about thinking, and I'm trying to figure out, is the ability to think in terms of like applying logic and being able to reason, is that a trained ability, or is it down to physiology? Because it seems like sometimes there are people who don't have the ability to think. And then on the other end of the spectrum, you have people who overthink. So what determines our ability to think and reason and logic things out?
Hi, Zuki. Well, I think if you think about what animals do, because they haven't gone to animal school, they have watched other animals and they do learn from other animals. Animals do definitely become educated by watching what their colleagues do. So they have evolved to connect cause and effect. And that's the basis of learning, isn't it? When you do something and there's an outcome. You touch a hot thing, it burns you, and you snatch your hand away, you don't touch it again. You taste something, it tastes lovely, you do it more. You taste something, it tastes horrible, it makes you sick or whatever, you don't go near that thing again. So we've evolved to have this ability to try something and then flinch from it or reinforce the behaviour that got it, depending upon the outcome. So we have that sort of primitive logic or reasoning, which serves us very well because animals do that, we do that, and we're all still here and we've been around for millions of years. So this sort of logic must work well to help us to get through life. And there's an innate caution around certain things which is hardwired into us. Some great apes, for example, if you show them a snake and they've never seen a snake, they are very scared of snakes. They will know this is dangerous. So there are some things which are hardwired into us to be scared of. There are some things which we know we want to do regardless. We want to drink. We like water. We know that's good. So there are clearly some things which are hardwired and a pattern which is written into us for things we do want to do, things we don't want to do. We like being warm but not too hot. We don't want to get too cold. We don't want to be too thirsty. We don't want to be too hungry. And we learn how to use those stimuli to guide us to do something. But whether or not some people are better at learning, I suspect they are. And there are some people that make those connections faster. There are going to be some people in the population that are more daring. Boys usually take more risks than girls do. And sometimes out of taking risks, great discoveries are made, but also great accidents happen. And by learning off each other and off our own mistakes, you bring all that together and you do develop a process of overall growth of knowledge in the population that then you pass on through social learning. But certainly I think there are going to be individual differences, and some people are very, very pusillanimous. They're scared of risk. Other people are risk takers, and that does vary by gender or sex and age.
Let's go to the WhatsApp line. There's a voice note there.
Morning, Clarence. Morning, Dr. Smith. My question is, nicotine in cigarettes. Say, for example, you've been smoking for many, many, many years. And I've seen some pics and images of what one's lungs look like when the nicotine has obviously grown there for many, many years from smoking. Now, if you stop smoking, how long will it take till your lungs recover again? Or should I say, get back to normal from all the nicotine, many, many years of smoking? I'd like to know how long will that take for your lungs to recover. Anyway, great show, Clarence. Cheers, John Kelsriver. Bye.
Hello, John. The good news is that it's never too late to stop smoking. From the minute you stop smoking, there is a demonstrable benefit to health. And there's an immediate gain in terms of things like heart attack risk and stroke risk, and then a longer term, slower gain in terms of lung recovery of function. And with all these things, the longer you've been smoking, the longer it takes to get back some recovery, and the extent of any damage done before you stop smoking determines the ultimate benefits that you'll get and how much recovery is possible. Because obviously you could take it to the extremes. If one has really bad emphysema and chronic obstructive pulmonary disease because of smoking, then by stopping smoking, yes, there will be some health benefits, but they're not going to be as extreme as someone who smoked for a week and then said, I'm never going to do this again. First thing is, nicotine is not the most deleterious agent in cigarettes, in the sense that it doesn't do the harm to your lungs necessarily. It does some, but what nicotine does is it keeps you harming your lungs by keeping you addicted to the cigarettes. Nicotine is a neuroactive chemical which plants make, particularly the nicotine-producing plant tobacco, because it's an insecticide. It poisons the nervous systems of animals that are trying to eat the plant. That's why the plant makes it. Caffeine's another example, another drug that we get from plants and love. And the drug goes to the brain and rewires parts of your brain, encouraging you to keep on taking the nicotine. The nicotine, unfortunately, comes alongside thousands of other chemicals, which are the products of combustion when you draw smoke into your lungs. And it's those other products that have a lot of the deleterious effects on the lungs. They do things like affect the way in which the cilia, the tiny tubular structures projecting off the surfaces of the airways, beat and clear the lungs. It also directly damages the DNA of those cells, and this is why smoking is a big risk factor for lung cancer. And a lot of the other chemicals in smoke go straight through the lungs and into the bloodstream, and they affect the stickiness of blood. They make your platelets, which are the elements of the blood that are one of the first responders to form blood clots, much more active. And so this increases the chance of blood clotting, and that increases the chance of blood clotting where it shouldn't, which is why it's a big risk factor for heart attack and stroke. So the minute you stop smoking and stop putting these chemicals into your body, things like the blood stickiness immediately improve. And within a very short time, you're back to normal, in inverted commas, on those metrics. But it takes a number of years for your lungs to recover to the extent that is going to be possible. And the shorter amount of time that you smoked for, the better the ultimate outcome will be in terms of function. But everybody benefits from the minute they stop smoking, and everybody should try and stop smoking because it's the worst thing, absolutely the worst thing you can do for your body.
And we're going to take one last voice note, and then we're going to have to call it a day. Let's go there. Joe.
Good morning, Clarence and Dr. Smith. The 2nd of April was World Autism Day, and I have a son with autism, so I'd like to ask the following question. What is known about how the autistic brain differs from the neurotypical brain, and what, as far as is known, is the etiology of autism? Thank you so much.
Good morning. Well, this is a complicated one, and it's one of those things which we're continuously learning more about. And it seems like it's become a lot more common in recent years, but one doesn't know whether that's because more people are falling into the spectrum of autism and something's causing that, or whether we're becoming much better at picking it up, or whether it's a combination of both. Now, what we know about autism is that there do appear to be some genetic preponderances. So it's clearly something developmental. It's something to do with how the brain wires itself together. and it kicks in fairly early on in our lives, which argues that, again, it's a developmental thing, it's not an environmental thing per se. The other thing to bear in mind is that if one looks at the brain of a person with autism and the brain of a person who doesn't have autism, then you're not going to see some gross structural difference between the two. But what you can see if you do careful imaging studies is differences in the way that different parts of the brain talk to each other. And scientists have been probing this with what is called functional imaging. And if you ask people who are autistic or have autism tendencies to do some various cognitive tests for you, you can show that different regions of the brain have different patterns of connectivity compared to individuals who don't have autism-like features. So it may be that, we don't know exactly why, that during development something reinforces some pathways in the brain at the expense of others, or causes a prioritization of the development and strengthening of certain connections connecting some regions of the brain but not others in people who have a likelihood to become autistic. But we don't know why this rewiring or miswiring or reinforcement or altered wiring occurs. There's clearly a genetic component, but does that genetic component change a person's behaviour, and their behaviour then, because the brain when you're very young is very plastic and can be moulded, and that makes that happen? Or does the genetic preponderance together with an environmental effect make the brain develop in that way in the first place, and it then, because of the way our brains then reinforce their own behaviour, become better at doing that? At the moment we don't know for sure, but scientists are looking very hard to try to work out how these different patterns of connections are formed and why they have the consequences that they do, and why it is that boys, for example, are more prone to this than girls, although not exclusively, and why there are some conditions that overlap with some of these features, but not all of them. And trying to understand and unpick all of that is a hot research topic at the moment.
And we're going to have to rest it there. Big thank you to the Naked Scientist, Dr. Chris Smith, lecturer at the University of Cambridge. Every Friday we have that appointment with him just after 9:30, and you get to ask that question that keeps you awake at night. It is time for news. It comes your way at the top of the hour.